everyone. Welcome back to Cosmic Sandbox. This is webinar 2, session 2. My name is Maximilian Berthe. I am a mentor of APOSA, the Asia Pacific Oceania Space Association. And it's my honor to welcome you to this workshop today. So a little bit of background about APOSA, just as a reminder. So APOSA was started in the wake of the 6th Asia Pacific Space Generation Online Workshop, which was held in November 2020. And at that time, several of our members came together in one of the working groups of this event, and we realized that there's a need for a platform for connecting individuals in Asia Pacific to discuss issues related to space and to co-create new solutions together. And so building on that, we delivered a statement at the UNESCAP 25th session of the Intergovernmental Consultative Committee on Regional Space Applications for Sustainable Development. And we've also conducted some research, which we summarized in a paper at the International Astronautical Congress in Dubai last month. And so the purpose of this series of webinars is twofold. Firstly, to provide a platform to connect with leaders and experts in the field of space technology, space law and policy, space business, and other fields of space, and building on these connections to develop new proposals focused on the idea of Earth observation for disaster management and risk reduction. So that concludes the brief introduction of Cosmic Sandbox. And in particular, in this session today, we will be focusing on technology and business. And it is my great pleasure to welcome two distinguished subject matter experts in these areas today. Our first keynote speaker will be Taras Matselyukh. So Taras Matselyukh is an inventor and subject matter expert in the field of application of advanced AI in profitable markets. For over a decade, Taras was a telecom systems operator, and during this time, he noticed costly consequences of human errors in complex data-driven environments. Informed by these experiences, he became a successful freelance consultant whose services were in high demand by leading telecom equipment vendors all around the world for more than 5 years. After founding OptNet BV, which became incorporated in 2018 and develops advanced AI products for application across a variety of critical and data-intensive industries, Taras became the first human whose knowledge and skills are being transferred to the Optos AI he built. So let me welcome Taras again today as the subject matter expert in space technology, and he will be talking about how to apply the OptNet AI engine to Earth observation data for Copernicus, which is the European Union's Earth observation program. So Taras, the floor is yours.
Thank you very much for the introduction, Max. I hope we took it with a grain of humor, but all the humor is great, but especially when the humor becomes a reality. This is what becomes a really making groundbreaking changes that change how the entire human civilization works. So let me start the presentation if I can figure it out. Yes, so you should see the Cosmic Sandbox presentation, where I'm going to tell you about a very interesting development, which is a recent European project called Centurion. And I'll give you some background about what's happening and why I think it's very cool and interesting to tell you about. So before just to reintroduce myself briefly, I'm from the Netherlands. As you know, it's the country which stays below the water. I'm a CEO of my startup. The startup has already been functional for many years. And we are specializing in making humans superhuman, right? So how do you make humans superhuman? Very simple. You just help their brains with advanced AI. And we educate AI and transfer some of our knowledge to the AI, like we did it, like Max said in the introduction, so that I or you or anybody else could do much more complex data analytics work than we typically could process ourselves in a year. And we could do this analytical work in a matter of minutes or hours, thanks to powerful AI. So, and everything that I'm going to tell you about, sorry, I'm losing my voice because I was at the Bremen Space Expo all week, and there was so much interest in this project that I lost my voice quite literally. But I will be, although I will be struggling a little, I hope you pardon me for that, because what I'm going to tell you is nevertheless is very interesting. So let me talk. Before we go into the topic, I would like to tell you specifically about some of the new technologies, which is the focus of this presentation. There are a couple new developments which go beyond the state of the art, which commonly exist today. And this will be thanks to the data cubes and AI. And I will tell you about what these are in the scope of this presentation. But let me, before we dive into this, and in order to better illustrate the problem that we are solving, I would like to ask you how many of you are having or working towards advanced or PhD in the geosciences? Maybe you can raise hands, so I know how this Zoom thing works. But even if it's a rhetorical question, ask yourself. And now, how many of you have advanced degrees in data scientists or working towards them at the same time as PhD in geosciences? And last but not least, how many of you have advanced degrees or working towards the advanced degree in AI? Well, the reason why I'm asking this question is that in order to become a successful and prominent GIS data analyst, you need to be expert in all of three. And if you want to use your knowledge and in creation, for example, if you want to start your own company, or you want to become a more than average scientist, you'll probably have a need in about 5 to 10 years of software development experience. Of course, people like Max, who are distinguished scholars, eventually come to this stage of nirvana after 20 years or so of hard work in this field of research. What we want to do now, what our countries, what society needs now, is to come to this nirvana of GIS analytics much faster. And well, by the way, if some of you do have these degrees already and you are so smart, please let me know, because we will hire you immediately. We like to hire geniuses and superhumans. But you could also become a superhuman, and this is why we started this project. Let me figure out how can I switch to the next slide. Yeah, so jokes aside, the scarcity of multidisciplinary expert knowledge prevents rapid progress and inhibits our abilities to create new services for society, industry, and in general, and particularly, I would say that this is relevant in the field of Earth observations and many adjacent areas where the price of human error is extremely costly. We all remember what happened to the Deepwater Horizon drilling rig, when it was the incident that would be remembered in the history of humankind for many years, next to the similar ones like nuclear disaster in Chernobyl and Fukushima. So we really should understand how the complex interplay of myriads of factors can influence the industrial development and what would be the consequences. This is why we proposed the Centurion Project in the beginning of 2019, which was eventually selected and funded for the development. And the consortium was recently funded, and the work on the project began about 3 months ago, which is very exciting news, taking into account all the delays and challenges introduced by COVID. But our team is very excited to work on this project, which would bring new technologies and novel platforms for big data and AI analytics for Copernicus constellations of European Earth observing satellites. But not only this, it will touch all of the Earth observation satellite data that today exists through the number of partnerships and federations. So I will tell you about this later, which makes it relevant not only for European citizens and students in Europe, but also makes it very relevant throughout the world. And this is why I'm here today with you, presenting about this project, because we hope that some of you will get inspired and interested to collaborate with us in the coming year. This project will take 3 years to complete, during which 10 European partners will work as a consortium under technical management of my company, OpNet, and as coordinated by the project coordinator from Belgium, Inlecom Group. The main, the main goals of the project are, first, to make analysis of the large Copernicus data volumes easy. Second goal is to make access and work with the platform easy for everyday scientists, developers, and human users. And the third goal is to open new market venues in the process by lowering the barriers to entry and lower the effort required from the market players to develop new and innovative services. So this project will demonstrate these ambitious goals in a set of specially chosen use cases, and actually the disaster monitoring is one of these cases, which makes it also very relevant to the topic of this event. The project is funded already for more than 4 million euros. And in our consortium, we also have other partners, which works. Yes. So in the consortium spans 10 countries. And in order to deliver these ambitious goals and provide the demonstration or use cases, which are very large in scale, the consortium gathered multidisciplinary experts in the fields of geodata scientists and big data, artificial intelligence, ICT platforms like delivery as a service. So these are industrial ICT players which are involved, cloud service providers, public communication specialists, as well as specific domain experts and scholars throughout Europe in different areas of remote sensing and data processing. But most importantly, there were several semantic users interested several thematic users interested in the development of the specific solutions in the target areas, who have the practical interest as well as scientific interest in using of the developed use cases in operational phase after the research phase of the project is complete. These users are WSL Institute, this is authority, snow and forest and snow management authority from Switzerland, and Julius Kuhn Institute, which is agriculture policy making arm from Germany. So the specific use cases in these two countries will cover entire area and will impact the lives of millions of people here in Europe in the scope of this project. We also have one of the DIAS providers. DIAS is a data information and access services portals of Copernicus constellation. They are based in Poland. And we have two universities and research institutes. So Jacobs University is providing data sciences expertise, along with Professor Peter Baumann, and Polytechnica Institute of Bucharest, which is closely collaborating with Romanian Space Agency. Actually, this is one of the arms of the Romanian Space Agency. And the team is led by the distinguished professor Mihai Datcu, who is also working as the scientist in DLR, which is German Space Agency. He is specifically experienced in this application of SAR technology. So team will have a very strong remote sensing experience, which is all weather and day or night capable. Why is it not moving? Let me click it. Okay. So I would like to also talk to you today finally about the technology. Enough about the project. Let's talk about some real interesting stuff. So this project will consist of three main technology enablers. The first one is DataCube. Well, the data cubes by itself, as they called analysis-ready data cubes sometimes, is not a very novel concept. There is a number of implementation, and I'm aware of at least three, including commercial or research and open source projects, which have attempted to implement the concept of data cube. So what is data cube? In the GIS, or especially in remote sensing, The data cube is the time series generated by a single instrument. So for example, if we take Sentinel-2 camera, which is flying on Sentinel-2A, it will make pictures of the same scene, of the same place on Earth over time. And if we take each of these pictures and slice them in time, we will receive the sequence of the data frames, which commonly are referred as a data cube. It's a multi-dimensional, typically three-dimensional tensor, if we are talking about imagery, but also could be four-dimensional in case if you talk about voluminous data, which has 3 dimensions or in space and plus 1 more dimension in time. But this is where our project will take this concept much further than this. Our ambition is to create multi-dimensional tensor arrays, as I like to call them, data hypercubes, to highlight that this is many extra dimensions which we add into the data cube structure, which extend the concept of analysis ready data to the additional sensors. So for example, with our proposed innovation, we will, and we are already doing this in our existing products and projects, we create and fuse the data sets from various heterogeneous instruments into the same set of homogenized data that is easy to address with computer algorithms. So for example, we could create a 50-dimensional tensor array where we will have all bands of Sentinel-2, Sentinel-1, commercial, drone, UAV, and even temporal series coming from in-situ measurement sensors. I'll show this to you later in the demonstration how it looks like, but this gives tremendous abilities for the analysis of this data, especially by the AI methodology. Imagine that you could get immediately all characteristic in multiple spectral spectra for each square meter of Earth surface. If you give this to AI, you could create amazing new models which learn on combination of different properties, ranging from backscattering of electromagnetic wave in optical, radio, X-ray, or even in the future muon specters. This creates some very exciting possibilities. So that was the first innovation that I was going to tell you about, and the first pillar of technology enablers. The next one I would like to tell you about is something that my company pioneered about a decade ago. We noticed the complexity of working with AI models and data. So from the very beginning, we started creating our AI tools in a way that we could easily package them. So what it means that we took complex, refined methods, added parameterization data, settings, pre-trained inference models, predictor models. So anything we worked on, we made it to follow a particular internal standard, which allowed us to easily port the created AI instruments from one instance of the tool to another. We could easily replicate complex scenarios and build faster. So we call this innovation AI knowledge packs. Although it is by itself not groundbreaking, but the discipline required to create such data constructs is very significant. And now we have a platform which could easily deliver this functionality for multi-functional applications. So the analysis-ready data, the AI knowledge packs are capable of reaching desired analytical goals autonomously, especially after being polished, and we call this phase educated by qualified and certified human experts. And I will show you the results later, but even these procedures could include the parts which have remote relation to the AI, but AI is always used in order to help us to find the data and to index the data and to present this data to the users. So this is going more than just analysis of the data itself. It also goes to the presentation. It enables us to basically allow the system to listen to human commands in natural human voice, which I demonstrated during the conference last week, that I even lost my voice. So that is a problem, isn't it? But let's move further. Now, we would like to get to the third pillar of the innovation and technological enablers, where we discovered that combination of data cubes and AI knowledge packs provides even more potential for the rapid deployment and rapid replication of human knowledge. This is where the innovation becomes, I think, extremely relevant to what you are doing. Because creating the knowledge, replicating the knowledge and storing this in AI constructs allows us to reuse this knowledge much, much faster. So, for example, if someone of you has a new idea how to implement the remote sensing methodology to monitor Earth disasters, you could take one of the open source AI knowledge packs and get some of the open AI analysis ready data and combine it into the AI cube, which could be executed. This approach will work kind of like an app store for human knowledge and analysis ready data for geospatial analytics, and all would be easily available in one space, enabling scientific research, exploration, as well as commercial uses, creating new markets and new ways of exploiting the data cubes and AI cubes. And most of all, making accessing this market easy for the users and new entrants. So this is very exciting, and I hope you are interested to participate in this program, and we will address your questions during the break. But this is the main purpose of us, to let you know that this platform is coming and you will be able to benefit in your research, education, and potentially even commercial activities. I would like to present the system architecture, which basically represents a kind of a fabric. First of all, it is going to be built, and it is actually already being built and integrated, and some of it is functional already within the project. We are building on 3 market-ready platforms and products, which were developed by my company and Razdaman in the previous decade. All of these projects, actually all Optos AI, Tsar AI, and Razdaman, are former Copernicus Masters winners. If you don't know, Copernicus Masters is the European-wide competition where innovators and startups from all over Europe are competing for Copernicus prizes, which are pretty significant in the monetary value, as well as very prestigious. This is kind of the Oscars of Copernicus industry here in Europe. So if some of you are based in Europe, I will highly encourage you to try your luck, and especially if you have something really good to offer. But enough advertising of Copernicus Masters. I would like to tell you more about what is this architecture is really doing. So let's take a look at the bottom of this slide. Here you see the sources of data, which include DIAS platforms, which we currently have, or I think we have 4 of them in Europe, located in different countries, which already provide data access to all users who are especially public, because this is open data. Most of the data is open. But getting additional sources of data, such as NASA open data and ESA contributing missions data, is more challenging. So we already implemented the Finder interfaces, APIs, which allow you easy to index the data and receive your data with the minimum effort and create the analysis-ready data automatically. We are also, through Razdaman, we will implement the access to analysis-ready data from Federation members. There is an Earth Server Federation of data centers, which already provides analysis-ready data within the federation. So, for example, there is a Taiwan Supercomputing Center, which is a member of federation, which you could query for processed and analysis-ready data, which was already generated there for vegetation indexes, for generic observation data. So this will make it possible to access any data in the world that is known to the system with ease. And in case of commercial data, you would be even able to purchase or request the quotations for the commercial data which you need for your commercial projects and receive this data. There would be also support of credits for research and enabling advanced studies which cover much larger areas of interest. The AI cube processing and value-adding generation layer will also enable access to the compute resources, because we are currently working with the leading cloud platform providers such as Amazon, AWS, all of the DSs. So actually in this project, we have a mandate to involve 2 DSs, and this would be CryoDS, which is located in Poland, and Mundi, which is built on T-Systems in Germany, on T-Systems infrastructure in Germany. So with this platform, we will have ability to provide petabytes of storage and significant compute capabilities on the par of a supercomputer level. The access to the data generated would be possible through the admin consoles, through the AI cubes themselves, and also would be open to third-party tools and applications through the set of APIs via secure and standard APIs. The project will only support OGC compliant standards for web-enabled services. So we will avoid, actually, there will be no proprietary standards implemented in the project, which would make the use of the data very easy. So all of these proprietary shapefiles from platforms like ArcGIS, which are difficult to work with and require you to buy commercial products or AutoCAD, so they will be, even in the scope of this project, we are planning to develop new standards which are open and OGC compliant, so that we could make the new data sources available. The number of clients would be able to access the platform in a fabric-like way through machine-to-machine clients, human clients, which support very easy visualization interface and a natural human language understanding by the platform. So if you will need, for example, to make a geographic queries, all you need to know is to ask the system to go to the desired city, specify the range. Perhaps you might want to draw the polygon of your interest, save it, load it in the system, and the system will automatically start looking for the data which matches your project and task criteria. So I have prepared a couple examples how this might look like in reality. How are we doing on time? So we still have about half an hour. Okay, good. So we have prepared like a workflow, which I will show you during the demonstration. So there are 18 steps involved in the preparation of the, for example, the flood mapping product. So if you are looking for floods, you need to repetitively process Earth observation data and detect changes. So I will show you the output of this, but there are 18 steps. So if you would be doing these steps as a human with the traditional tools, it would easily take you 2 or 3 hours per each scene generation. Even if you script, for example, there is a very well-known platform distributed for free by European Space Agency called Snap Toolbox. I really like this tool, and I have been using it a lot in the early days of my business. And this is when I realized that even with this tool, and even if I will write the graph thread processor script, the one that I want, it still would take me hours to complete the job like I have on this screen, which consists 18 steps. And even then, I will be only limited to see the results on my own computer. I will not be able easily to publish them. Even if I try to create the Google Earth visualization, the ability of other users to see the results of my work would be limited. So you will see later in this presentation the ability how we can perform the analysis and share it with the users through the standard OGC compliant interfaces and web technologies. So I would like to highlight that the data that the system is generated is supported in a popular or open standards, and the sharing of the data is possible through the GeoTIFF or cloud optimized GeoTIFF tiles, which would be even taken further, because if you are using APIs of the platform, you could query the Rastaman layer for the required data through the OGC compliant interfaces such as WMS, WGTS, WPCS, etc. Right, so now let's use some of the time. I will show you about some interesting and exciting use cases which will be implemented in the Centurion platform. But let me grab a drink, please. Thank you. So the first use case is about the generating analysis ready by itself. So the result platform will enable will enable us to generate massive amounts of analysis ready data, which are combining and fusing various instruments into the same data set for a broad area, geographic area. So in this case, we plan to generate the analysis ready data for entire Europe, enabling a valuable data source. But of course, we will be doing this only on the open data due to the licenses of such a data. But instead of downloading individual products from Sentinels and Landsat and other sources, we will create the multi-dimensional analysis ready data cubes, which you could query with ease and use in your project, especially if you are located on the platform. The second use case is focusing on the agriculture weather index generation. So climate change has been recognized as a main driver in the increasing occurrence of extreme weather, and the agriculture weather indexes are used to assess these extreme weather conditions in application to the agriculture. So conditions like drought or soil erosion will be noted, and the impact to the crop yields will be measured. So this use case is will be led by Julius Kuhn Institute, and we hope that the weather indexes will be based on multiple variables and combine different variables. So designing these weather indexes is challenging, since complex crop climate relations have to be considered. And this use case will be providing and demonstrate how the Centurion platform could be used for creation of the dynamic weather services covering modern day and historical occurrences. Also enabling up-to-date predictive generation of the predictive indicators, which will help with creation of new agricultural policies. This case will be focused specifically on monitoring of the vegetation cycles in Germany. And I believe the results of this project will influence policy making at the scale of the entire European country. The next interesting use case is about the shipping dynamics. So we have several interested users here in the Netherlands who would like to see the ability to monitor the activity of the vessels covering the entire North Sea. North Sea is an interesting water body because it provides the transportation and food for a large number of European countries, ranging from UK, Denmark, Sweden, Germany, Netherlands, France. So there are, of course, many interesting use cases that we see here. For example, there are very valid use cases in the monitoring of the fishing quotas, which would prevent the unregistered and illegal fishing and will save our environment for the future generations, because extended fishing, which exceeds the quotas, have disastrous impact on the ecology and the species diversity, essentially impacting everybody's future. So this case will attempt to identify all potentially unregistered vessels, or the vessels which are tinkering with the AIS signal in order to violate the shipping quotas. Anybody wants to ask something? Sorry, I heard a question. Oh, okay. Well, I will return to your questions in the chat when we finish the presentation, because it's easier for me to do it this way. So there will be not too many slides. I will be finishing in maybe 5 or 10 more minutes. The next use case is near real-time monitoring of forestry dynamics. So it's a very interesting case for Swiss WSL Institute because of many things. Of course, there are problems like illegal deforestation, which is less of an issue here in Europe, but the extreme event really also having a dramatic impact on forestry management practices due to the pest outbreaks, due to fires, due to large impact of the large-scale die-offs of the trees and forest, and which impacts the further biodiversity and carbon cycle. So this is another great impact project, which has huge environmental impacts. And also it has the potential to be applied to detect illegal deforestation. And I even think it has impact on the disasters, because deforestation is one of the confirmed causes of flooding or excessive damage to the flooded areas due to lack of vegetation and trees. And final use case, which has direct application to the purpose of this event, is near real-time flood zone mapping and attribution. There are many services which are conducting flood mapping and monitoring today, but all of them still would benefit from a centralized rapid calculation platform, which could integrate the data from multiple sources at the blink of the eye and provide the substantial compute resources when necessary to generate the near real-time maps and attribute near real-time impact. So what do I mean by real-time attribution is ability of the platform to calculate the impacts to the residential areas, populations at the building and the road and street address layer, prioritizing the rescue operation, immediately assessing the seriousness of situation. This platform alone could speed up the critical decision making by days. We have tested the early prototype of this service, and we could detect the onset of critical flooding conditions, usually 12 or 18 hours before the state of emergency was declared. And one of the main reasons is that we are using advanced radar sensing methodology from various sensors, which allow us to see through the cloud, because flooding occurs typically when it rains a lot. But if we wait just for the optical imagery, which is often used for damage attribution and flood assessments, we will have to wait for days in some cases, especially in the tropical areas where cyclones could last for many days. So this ability of the platform to see through the cloud has already confirmed the ability to expedite the decision-making and save lives and property. Well, on this, I think I have finished and I came to the end of my presentation. And we could have a little bit of Q&A session at the moment if you have some questions about the theoretical part, or switch over to the quick demonstration. So I suggest to answer some question, because the demonstration can take easily the rest of the time. So I would like to have you ability to ask questions. In any case, if you are not present and you are watching this in recording and you would like to follow the future announcement on the project, which also include the announcement of the hackathon, which would be planned within the next year, where we would like to extend the invitation to all of you to submit your applications. So more details about this hackathon would be announced at the project website, which is www.centurion-project.eu. Thank you for your attention. And if you want to reach out to me, so you could, of course, do it through the LinkedIn messenger, through the profile of the presenter, or send us an email at info@opnet.eu, or follow us on Twitter or LinkedIn. Thank you very much. And now I'm ready for questions.
Okay, thank you so much, Mr. Matselyukh, for your very interesting presentation. And thank you for telling us about how we can stay in touch. I think we'll look out for the hackathon. So yeah, please stay up to date with that, all participants. So now it's time for Q&A, and we collected some questions before the event. So I would like to start with a question we collected before. So the question from a participant was, what are the most commonly used numerical hydrometeorological models to predict tropical cyclones? So this is a little bit different from the content in this presentation, but I'd like to ask if you have any comments about that question.
Yeah, excellent question. So the platform that we are developing is able and open, and will be able to create any data analytical tasks that you require. For example, the cyclone monitoring was one of the ideas that we have been discussing with some of the European partners. Actually, we have another phenomena here in Europe. It's called, oh, well, I forgot this. It's, it has something to do with Mediterranean, like some medicons or something like this. So basically, it's a phenomenon that is atmospheric development here over the Mediterranean. And it has the same consequences as tropical cyclones, both causing droughts on one side and flooding on another side. So we will be developing this in the future with the European scientific partners, but we also will be open to collaborate with the partners from Asia. So if you have an interest in this, please let us know. And we would be keen to open the collaboration with your research institution and perhaps even create a specific project for that.
Okay, thank you so much, Mr. Matselyukh, for that answer. And I just posted a link to the Medicane phenomenon you referred to. So the participant who asked this question, please refer to this link for more information about it.
Yes, and if you're interested, perhaps we could even make a research project out of it. Which would join the international collaboration. So let's stay in touch, very interested. Platform should be able to help you with this, especially the more mature the platform becomes.
Right, and in the second part of this event series, we will be focusing more on solution development. So yeah, participants, please bear this in mind. And this is an interesting candidate for research. So next, I would like to move on to questions posed in the Q&A. We have one from Ahmed. So Ahmed's question is a digital Earth platform a good map for disasters? So I don't know if you have any comments about this question.
I think Ahmed is mentioning the project called Digital Earth or Digital Twin. I've heard about this project. It's one of the European Union funded project. Yeah, I could be wrong, but I remember the name. So this is the parallel effort. As a matter of fact, what I know about this Digital Earth project, that they are working on a digital twin, essentially creating a statistical model of our environment based on the data that they have gathered, models that they developed. And well, I'm sure it will provide valuable modeling tool, but the concept of Centurion is different. The concept of Digital Earth is to simulate the Earth. So this will be a supercomputer which will simulate the Earth. While goal of the Centurion is to monitor the Earth, is to provide you the platform to actively analyze the changes. So in the concept, these two projects are fundamentally different, although there is a great synergy because the data from Centurion could be used in Digital Earth, and data in the Digital Earth and models could be published in the Centurion as analyzed data. But I would like to highlight the difference that simulating and analyzing in real time are two different methods, and they are both valid, and they have valid reasons to do one over the other.
Right. Okay. Thank you for this response. And I imagine we will also see more synergies between this presentation and the next presentation. The next presentation is on data acquisition, so that will also be interesting. So thank you for that. So we have another question.
Absolutely. Please don't jump into a conclusion. Any tool is useful. As statisticians say, all the statistical models are wrong, but some of them are useful. So let's use those which are useful.
Right. Yeah, that's a good point. So thank you for that response. And I would like to move on to a question by Jim Volp. So Jim's question is, what cloud provider is Centurion using?
Excellent question. So the Centurion is being designed from the ground up to use many cloud providers. We are developing the heterogeneous cloud orchestration engine within the Centurion project duration, which is 3 years. We have the goal to deploy the project on 4 clouds. So there will be 2 DSs, which one of them was already engaged in the deployment effort. It's Creo DS. There will be Mundi, which would be another cloud provider. And we will also involve at least 1, and my personal objective is to involve 2 cloud providers. We are in negotiations with Amazon and IBM Cloud, and potentially Google will also join. So the more the merrier. The idea of the project is to provide the access to the computing resources and make this access easy. So the ambitious goal is to enable the users of the platform to create the essentially like Docker container or microservices jobs, which could be published through the orchestration engine, kind of like in a matchmaking manner. So for example, you publish the job which has specific technical requirements. For example, it needs this much CPU power, it needs this much storage, and you are prepared to pay €1,000 for it. And you launch it into the orchestration engine, then the cloud providers which are participating in the platform will be able to bid for your project. And once the match is made, the job would be executed on the platforms of that particular cloud provider. The ability of the platform to access the data through the federation of resources minimizes the need for duplication. Actually, the tendering protocols that we will deploy will match the jobs with the best providers, so there will be minimum waste and extra effort. So this is one of the very interesting aspects of the project, which is also building up upon some pioneering cloud and IT work that we've done with the University of Amsterdam. You can read more about it when you read about open cloud exchanges. So if there are any IT scientists among you, you probably heard about them. It's OCX. You can look it up. You might even find some literature in the research portals.
Thank you very much for that response. And Jim said, excellent, thank you very much. So very good. I'd like to ask one final question before we move on to the next session. So this is an official side event of the Asia Pacific Regional Space Agency Forum. So I would like to end with the Asia Pacific dimension. So many of the use cases you mentioned are highly relevant for Asia Pacific. So you gave examples of forest assessment, agricultural monitoring, and flood mapping. So these are all very relevant issues in Asia Pacific. And standardization is one theme that was running through this presentation today. And to my knowledge, this is also a big challenge in Asia Pacific. So many institutions and governments, etc., have data, but maybe the format is not adequate to exchange between the different stakeholders. So has this challenge also been encountered by OptNet in the Centurion project, and how has it been addressed?
Yes, of course. As I already said in the presentation, our main focus and our mantra on this project is to only use OGC standards within the project. So data exchange will be standardized, and there will be no exceptions to that. Any data that doesn't have a standard would either be not on the platform or converted to the standard, or we will be creating new standards for this specific data. My particular interest is to create or extend the shape format standards, as well as 3D data format standards. So this is included in the objectives of the project, but standardization work and these advanced topics might create more time. But if somebody is interested or has ideas for collaboration in the standardization area, please let me know. We are very interested to collaborate with you. So if you allow me a few more minutes to end on the Asia Pacific node, I wanted to demonstrate, I promised I will show you the platform demonstration to which you can talk in human language. So for example, I can say hi to the bot and it would greet me theoretically. And I would like to, you can, in the future, we will launch this platform for you to use it. Actually, I should help me. Yes, so I would like to show some of the analysis. It's a demonstration use case that we did in Vietnam for flooding in 2018, where we could show you how the tool will help to detect the flooding. So some of the particular methods used here, showing how I can easily access the published documents on the topic, which are available in our archives. And I will also show you how easy it is with the platform to analyze the flooding events. So for example, this is the image of processed data, which is pre-flooding. It's an archive image in synthetic antenna aperture produced with our AI knowledge packs, which creates a synthetic composite image with very specific visualization tools. If I will compare this with the flooded image, so this is the crisis image, so which comes on top, I can zoom in particular area. For example, let's see, this is one of the areas which got flooded. So I don't need this anymore. So let's zoom in. So if I would like to demonstrate you how easy it is to see where things got flooded. So for example, here it's a pre-flooded image. When I am using this lens tool, which is showing how the river looked before the flood and how it became much larger. What you also see the color changes. These color changes, in fact, are very important because it shows you the state of the water surfaces, whether it's flooded vegetation, whether it's the flooded urban structures like here. So of course, it's begging to apply advanced AI tools to analyze this imagery. And this is what you could do with the tool. So we have created an AI models which simply create clusters. So I will only show you the subset of clusters. And the cluster which defines the flooding is depicted by cluster 9 here. So I will just enable it. And you see it's a mask which could be used for calculation of the impacted area. So if you take and switch to let's say, the street map, and within this lens, we could enable, and I say, I would like to see to the street map. Sorry, I would enable this one, it's on, Thunder Forest. Yes, I disable the flooded area. Actually, we can do both, right? Why not? So here, what I can analyze where my streets are, where my floods are. I don't need this anymore. Sorry, live demo. Not always you do what you want. So you can see where the flooded areas are. You could see the street names and the addresses. So if you extend this knowledge pack to automatically use street maps, you could immediately attribute the damages. So you could see where which streets have been flooded, which buildings have been flooded, etc. So thank you. The question about the colors in the SAR images. Yes, color of the SAR images are, well, usually trained GIS experts know what this means, but I'll give you a couple of tips. I've been creating this methodology. So yellow shows you the areas of yellow and white. This is the areas where the urban areas and high-rise buildings, like lots of concrete, are. The red are typically open soil, sand. The green are areas with a lot of change. So where, for example, vegetation is changing or a lot of moving objects on them. But typically this is grasses, forests, and other types of vegetation which change.
Okay, thank you very much, Mr. Matselyukh. And so we have a few more questions, but we would like to return to these at the end of today's session. So
of course,
please keep posing questions in the chat if you have questions, participants, and we will return to these later today. So for now, I would like to warmly thank Mr. Matselyukh for his presentation, and I invite you all to virtually clap if you can, or to manifest yourselves and say thank you to Mr. Matselyukh. So thank you very much again for your presentation.
Thank you very much. I know you have to stay on time. I appreciate the interest of the audience, and I wish you the nice weekend and pleasant continuation of the session. Thank you very much.
Thank you. Thank you so much. Right, so we will now be moving on to the second part of today's proceedings, and we will be beginning the space business part. So it is my great pleasure to welcome Luciano Giesso from Satellogic as our subject matter expert in space business. So Luciano Giesso serves as the International Sales Director at Satellogic, an Argentine company specialized in Earth observation satellites, which was founded in 2010. Mr. Giesso is a multinational executive with more than 20 years experience in technology and services. He is Argentinian, and he has lived in the United States at different times in his career. Mr. Giesso has led multi-country teams of 100+ employees in many countries and has occupied several management and sales positions in technology companies, such as a 14-year tenure at IBM. So we welcome Mr. Giesso today as our space subject matter expert in space business, and he will be sharing with us a keynote presentation on Satellogic's efforts to create a searchable Earth, which involves lowering the barriers for utilization of Earth observation satellites. So Mr. Giesso, the floor is yours.
Thank you very much, Maximilian, and thank you, Sindhu, and Aline and Pond, and everybody who was involved in inviting me here today. So the first thing I'm going to do is I'm going to share screen. I hope that this works well for me. So please let me know when you're looking at my presentation.
Yes, we can see your presentation.
Perfect. So let me move to present mode there. Okay, so again, thank you. I'm going to talk about today. I'm going to give a bit of an overview of Satellogic and who we are and what we do. And I'm going to focus at the end of the presentation on how we address or what kind of value we bring to disaster management and risk reduction. Okay, so I'm going to try to keep my presentation within 20-25 minutes and give space to Q&As later. So with that, Satellogic is a vertically integrated geospatial analytics company. What this means is that we look at the world in different ways with optical satellites, and we try to make sense out of the imagery that we obtain from it. And what we're trying to do is to create a searchable Earth. We like to call it like this. This is because I'll get more into the details of the presentation, but we're able to produce satellites at a very, very low cost with very, very high resolution capabilities. So the ultimate plan is to have a live catalog of everything that happens on Earth with our satellites. So the company in a snapshot looks a bit like this. On the map there, you see the different locations where we're at. The company, as Maximilian mentioned, was founded in 2010 by the two entrepreneurs that you see over there, who are now, and today, Emiliano is our CEO and Gerardo is our CTO. They came from the IT industry. I'm going to talk a bit of how we translate those kinds of things into the things we do. There's a lot of competitiveness and things that have happened over the past decades in the IT industry that the space industry hadn't gone so much, across. So a lot of what we do has a bit of an IT mindset and an IT heritage in the way we do things, and I'm going to give specific examples. Looking at the map, the locations that you see on the map, most of them have some kind of specialization. Today, we're more than 300 people spread out in those cities and many others. So we have people working in about 35 cities in the world, many of them outside of the countries that you see represented here. But this is where Satellogic has a firm or an office. So in Argentina, where the company was founded, we have our engineering team and our operations teams. These guys are the ones, on one hand, the engineering team is the one responsible for creating and developing and designing every new generation of satellites that we launch. Whereas the operations team is, the team that is looking at the satellite 7x24, that is monitoring the existing satellites in orbit. All of that is mostly focused in Argentina. Our manufacturing plant is in Montevideo, Uruguay, in a free zone that allows us to drive costs really, really low in the way that we make the satellites, because we virtually pay zero taxes there. So that is the why we have built our plant in the neighboring country of Uruguay. By the way, and reflecting on my co-panelist Tara's nationality, our next manufacturing plant is something that is not in the map and that we're not disclosing much, but we are, I'll say it because it makes sense due to the fact that he's from Netherlands. It's being built in Rotterdam. So we're going to have another manufacturing plant there somewhere in 2023, ready to deploy satellites. Our third office in terms of size is the office in Barcelona in Spain. That office has the product team. This is the team that once the satellites have captured the images and they're downloaded in a ground station, they make sense out of it, or they transform it into some product that is to be shipped and delivered to some client. 70 centimeter resolution imagery, video, whatever our hyperspectral sensors capture, everything that is transformed into a product is done in Barcelona. I'm going to talk a bit about the products in the next slide. Then we have a software development platform in Tel Aviv in Israel. We have different offices and specializations in the US. I'm based in Key Biscayne, Florida. So I'm represented there by the office in Miami. We have sales positions spread all around the US and Europe mostly, but most of my team and the teams covering sales are in the US in different cities. And then we have our CFO and the control team is all based in our main office in the US, is based in Charlotte, North Carolina. And last but not least, and going to the Asia Pacific side, we have a team of sales and marketing in Beijing. So again, and these are only the cities where we have offices. Then we have a lot more people spread out in different locations. So we have launched 25 satellites to date, as it says on the lower side here of the slide. That is a pretty good, mark in terms of quantity. We're launching the next 4 in the first half of next year. It's probably going to be in April. We're launching with SpaceX. I'm going to talk a bit about that in a further slide, but we've been launching with SpaceX since June this year. So we've been, we have a multiple launch agreement that we're launching every time point forward with them. The ultimate goal is to have 300 satellites, and I'm going to talk about that roadmap at the end of the presentation. And there's a number of things that we do on the intellectual property side of things. And this is another way that helps us drive costs very, very low with our satellites. So we do not buy designs from anyone. We build and we design and we invent every portion of the bus and the payloads of the satellites that we do. So, and because we do that, we are very privy and careful with our own inventions and intellectual property. So we patent everything. So We have already earned 15 patents in different places in the world, mostly in the Northern Hemisphere. They're mostly related to the optical side of the satellites, but we also have some patents on other components of the bus. We have about 43 patents that are undergoing the process of ending up being granted, and about 15 to 20 inventions that will then undergo the patenting process. So again, we are very careful and private with our inventions. This is how the satellite looks like from below. To give you an idea of size, it's about 90 centimeters high times 50 times 50. Okay, it's about the size of a chair. It's a micro satellite. Every satellite of ours carries 2 cameras. One is a high resolution multispectral camera mounted here in the main telescope of the satellite. And this camera obtains imagery. It has 99 centimeters GSD natively in each of the 4 bands that it has in RGB and near infrared. Every band has a native 99 centimeter GSD. And we're able to compose with post-production and with using different frames, a genuine 70 centimeter super resolution image with this camera. Okay, so we have a lot of demand for this kind of imagery. And by the way, we have I would say one of the best frequencies in the market in the sense of obtaining repeated imagery from a given area of interest. So this is our main source of income these days, the multispectral camera. But the satellites also carry here on a side bay a hyperspectral camera. All satellites of ours have a hyperspectral camera in them. It's 29 bands. It has 25 meter resolution. So between the one that sees very closely and the other one that that can tell, for instance, a healthy crop from a sick one, or can tell different levels of humidity in soils, between the two of them is that we deliver solutions to our end clients. The mass of the satellite, some hard specs, is about 40 kilograms. We orbit in low Earth orbit, sun-synchronic at about 475 kilometers in average. The lifetime of the satellite, this has to do with our IT heritage. In the IT world, or on Earth, when you talk of technology on Earth, you don't keep your phone or your computer with you for longer than 3 to 4 years. You typically change. That's the kind of pace in which you would change that kind of equipment. Well, that's the kind of pace in which we want our technology in orbit to remain updated. So we replenish old satellites with new satellites at most in the 3 to 4 year window. And that allows us, because of this intent and because of this philosophy of keeping technology in orbit updated, is that we can lower a bit of, when I spoke about how low the costs of our satellites are, and I'll get to that. One way that we do it, one part is building them in Uruguay. Another part is patenting everything and inventing everything ourselves and not having to buy expensive technology or designs from somebody else. But the third part is that we keep our costs low by having the batteries only last for 3 years. The butane tanks in the back of the satellites, they have their own propellant here. They only have enough for that kind of time. The whole exterior of the satellite wouldn't resist the radiation of the sun and the hostile conditions of space for longer than that time. So everything, as from a statement and willingness of having updated technology, we're able to drive costs even lower. So getting to what the satellite costs and how we are able to compete in the market with a very, very high technology product at a very low cost. To give you an idea, we're in about 100 or 1,000 times less costly than a traditional satellite. So a traditional satellite would cost anywhere between $200 million and $1 billion maybe. Our satellites with this kind of capabilities, we put them in orbit, including the launch, for less than $1 million each. So that is why we're able to, to just decommission them so quickly. Okay. And before you ask, when I talk about decommissioning and replenishing satellites and everything, what we do is we move them closer to we let gravity beat them and enter a spiral where they will end up burning in the atmosphere. We have already decommissioned 8 satellites. And none of them, none of it goes into any graveyard orbit or any debris orbit or anywhere other than, burning completely in the atmosphere. None of it comes to Earth in the end. So this is a bit of a history of the satellites and the 25 that we did, how they were named, what generations they adjusted to. The first satellites that we did were within the CubeSat standard. They were experimental. We were learning how to do them back in 2013 when we started. We did this kind of mid-sized satellite, 20 kilograms. That was a bit of the leap to get into this kind of design, which is the micro satellites that we do. Every generation that we did since 2016 to today was always better than the previous one. And as you see here, Mark 1, 2, 3, etc. And the names that you see, I'm not going to get into the first names because they're very Argentinian. If some of you recognize those, thank you very much. But as of 2018, we started naming the satellites after famous women in science. So Ada here is for Ada Lovelace. This is Mariam Mirzakhani, Sophie Germain, Marie Curie, and so on. We have honored a couple of Argentinians here, Cora Rato and Elisa Bakofen. And we will keep with this intent and policy of naming our satellites after women in STEM or women in science for at least the next 100 satellites. I vouched for women in rock and roll, but I wasn't listened to yet, but I have my own battle, inside Satellogic to get that done. But until then, it's going to be women in science. By the way, every launch that we had, luckily, we had all launches were successful. In November, we had launched 10 satellites altogether into the same rocket. That was a bit of too many eggs in the same basket. Luckily, it went well. With SpaceX, our agreement is we will be launching in batches of 3 to 4 satellites. And as of the second quarter next year, we expect to do that quarterly. So we will be launching many. We won't be doing 10 in a single rocket again. So this is the next, the agreement, the 17 women that we have honored and that we are using today, because we're using, I didn't mention this, but I did mention that we decommissioned 8, so we're using 17 commercially. These are the 17 women that we're using today. And as I mentioned before, we'll be launching the next 4 in the first half of next year, most likely in April. So what do we do with the satellites when they're in orbit? We basically do these 4 things that you see over here, or these 4 products that you see over here. We're very much focused on the first and third one. So we provide very high resolution, high frequency, low cost satellite imagery. So we have clients and users of our imagery in every continent in the private and governmental sector in the world. So this is one of our main areas of focus and the most obvious one because we do observation satellites. The second one has to do with making sense out of the imagery. And there's many other companies that we work with where we provide the imagery and they provide the analytics. So in some cases we do the analytics too, but we're not so much focused on doing this downstream part of the service because there are many, many companies out there that do it, and that, they're niche companies that do it better than us for certain industries or certain regions. So this is something that we do, but not so much. This is something that, yes, we're very focused on. We call it dedicated satellite constellations. It's sort of a satellite as a service or a space as a service. Because in this, again, this has to do with our IT heritage. In IT today, everything now is cloud-based. You do not, every company out there is not really buying their own boxes when it comes to having their server farm, but rather moving to a cloud subscription model. This is the kind of model that we brought to space, and we were awarded for it at the time that we launched this back in 2019. What this means is, imagine you're a country willing to have your own Earth observation capabilities, and you don't want to invest $200 million in a traditional satellite or $500 million in a traditional satellite. Because most of the time that satellite, and this happens with Earth observation, that satellite will be orbiting somewhere else than your given country. So if we look at, say, a mid-size or small country like Spain, the time that a given observation satellite would be above Spain is probably around 1% of the life of, total lifetime of the satellite. So what we developed is a service where we give those countries the ability to operate our satellites, and by operating, we put every ground segment component in country for them to be able to monitor and task and use the satellites only while the satellites are orbiting above the land of the country or the area of interest that the country is interested in seeing. And then, relinquish control and give them back to us, and we use them for something else during the rest of the time. And the way it works, it's a fraction of a cost. It's orders of magnitude less to use a constellation of our satellites. And we're talking contracts here that we have signed with 12 satellites or 10 satellites doing this kind of work for countries, instead of just buying one. And it's a lot less money to use many of ours in this kind of service mode than investing in hardware. We don't sell our satellites, we provide them as a service. And this is a bit of how we how we think of things coming from a totally different industry. And last but not least, the other product that we do is something that we call the hosted payload program, which basically consists in carrying third-party sensors in our satellites. So I'm going to go back a second. I didn't mention this, but over here on this side, this is a twin bay, like the hyperspectral camera one, where we carry these sensors. So we have already closed 2 agreements, with one with an Australian company, another one with an Argentinian organization, where we're carrying sensors that it's a university in one case and a private company in the other. They built a sensor. They didn't have, a place to orbit it. We sort of lease space, if you will, in the satellite for them to use the satellite capabilities and resources and being able to use the sensor inside of our satellite. So I'm going to give you now some examples. I'm going to go quick through these slides. Some of imagery tied to commercial applications, and another section with imagery more pertaining to this session that has to do with disaster management. Okay. So in the commercial application side, these are all, by the way, these are all images of ours, of existing contracts that we have with different companies and governments around the world. These all have to do with monitoring port activity and container activity in ports. This is pretty similar with planes, both in airports and this, which is actually a plane graveyard of small planes for a plane company. They use these planes to cannibalize parts to maintain the existing fleet. These are more urban. Here we look for changes that have to do with infrastructure or green locations within cities. This one here, we're doing video. I didn't mention that, but we do 60-second video with a multispectral camera too. And here we're looking at how what the kind of volume of cars that goes from point A to B on a given time frame. These are more agricultural. This is except for this one, which is tied to minery. This is a forestry section of Brazil. This is an agricultural field in South Africa. This is National Park in California. And this is a mining facility in Botswana. These are hyperspectral. The colors that you see obviously are corrected for our eye to understand what the camera is seeing. And now to what we do for disaster management and risk reduction. I'm going to give real life cases. These are not commercial images. I'm going to talk about the kind of partnerships that we have in place. But spoiler, the main one for which we provide these kinds of images is the Disaster Charter from the United Nations, of which we're a part of. So I'm going to start with some floods that happened in different places during this year. This is the flood in Bonn that happened earlier. I think it was in July this year. So we were assisting on that. The intent is typically, to try to monitor as quickly as possible after the disaster has happened, to be able to provide more effective help with boots on the ground resources based on the most affected areas in each of the cases. This one is a hydro plant in India, in Uttarakhand, that also had a flood happening, and it was pretty much flooded altogether. So we helped out there with our imagery as well. This one is in Japan. The mudslide that happened, I think it was in July also. The one in India was, I think, in February this year. This also happened in July. Many floods around the world. These actually we provided for NASA disasters. NASA was monitoring this volcano in Guatemala, and as you see there with the dates, we did daily monitoring of this volcano. You can see there's a red strip over here that's lava. And this volcano was in eruption, and we did a number of others with them in the Caribbean and in Africa especially. This is the explosion in Beirut last year that we also have been monitoring and aiding on. This is a wildfire in Sichuan in China. And there's another wildfire coming up where we used our hyperspectral capabilities, this one in California. Also, this happens once in a while, vessels stranded in coasts. So this is the Wakashu on the coast of Mauritius. And this one, we didn't really offer any value, if you will, with this one, other than when the Evergreen got stuck in the Suez Canal, us and every other satellite company went out to capture an image, and people started tweeting and comparing the images. And I'm going to get to another part of, spoiler alert. We won some Olympics recently on multispectral satellite imagery. But when people were tweeting this, they started comparing our image to every other competitor of ours. And informally and in the social media channels, everybody preferred ours. So this is why I always show it. So lastly, 3 slides. Okay, just to the partnerships come in line with what I just mentioned. Both the disaster charter and NASA disasters in this case are users of our imagery whenever a flood, an earthquake, a fire, a tsunami, whatever would happen anywhere in the world. We lend our satellite services to be able to help with satellite imagery as fast as possible. Then we have a number of other partnerships in place. Of course, many of you are very familiar and members of the Space Generation Advisory Council. We have an MOU in place with SCAC. Then we are members of the IAF. We have partnerships with other US related organizations such as the USGIF and the OGC, and many others that you see here. And I'm going to mention a couple more in the end in the last slide. So to give you an idea today of where we stand and where we're going, as I mentioned, out of the 25 originally launched satellites, we're using 17 commercially today. The ultimate intent is to have 300 orbiting and looking at the Earth in real time. Today, we are able to look at the Earth and to revisit points of interest up to 4 times per day. That is very frequent. So this is how we help with it. Especially, we do not have any contracts that demand this kind of frequency. But this is the kind of frequency that we provide whenever we're called on to help with imagery in the case of disasters. In commercial contracts, we have a couple with daily frequency, but most of them, are even higher, weekly, bi-weekly. We do not see a need of that kind of revisit speed today in commercial contracts. Maybe we're getting there, especially in some areas like insurance. But it's very important for us to be able to do this kind of revisits for disasters happening in the world. So lastly, and to give you a close of the presentation, first of all, we're going public in 2.5 weeks. So we're all very excited because of this. We will be quoting in NASDAQ under the ticker symbol SATL. And this is a big leap for our company. So this is something that I like to close the presentation with. We closed a partnership with AWS. As much as UpNet and Tara has mentioned that he uses many different cloud providers, we've been using a bunch, but we're leaning more towards AWS in recent times. And basically we're trying to implement together a solution that they call the Amazon Ground Station, which is a virtualization of the ground station segment of, it's like the ground segment of the whole satellite process is virtualized as much as we do satellite as a service. This is sort of a ground as a service where, they have an ecosystem of ground stations, but you subscribe to a cloud-based solution, and we really like that because it aligns a lot with the way we do things. So this is the partnership that we announced. In the picture you see the head of this solution in Amazon shaking hands with our CEO. This was a month ago when we jointly announced this partnership. And last but not least, and I give a hint of this, in GeoInt, when was it? A month and some days ago, they ran this Olympics where they chose different categories for winners of different types of imagery. And we took the first prize, the gold medal for multispectral imagery on a global basis. So this made us very proud and very happy. So I close the presentation with that, and my data is on the screen, and I'm open for questions now if you have any. Okay, let me stop sharing here.
Okay, thank you very much, Mr. Giesso. We really enjoyed your presentation, and
You're welcome.
you touched upon not only space, science, and technology and business, but also consideration of society. So yeah, I was quite moved by the fact that your 17 of your satellites have been named after leading women in STEM, and you're plan to continue this until the first 100. I think that's a really inspiring initiative. So I would now like to open the floor to discussion. So for now, we don't have any questions in the chat. So I would like to inaugurate. Oh, and we have a question. So I will jump straight into the chat. So Rene from the Philippines asked, do you provide mentoring services or partnerships on companies, institutions from developing countries who have just started their quest to build their own payloads or satellites?
Yes. So you know, our biggest market in terms of the kind of services that we provide is typically developing countries. And when we talk about, you know, mentoring institutions, many of us do that personally. Like I do that personally a lot. I'll give you an example of one thing that happened in South America. So there was this foundation called Open Space that decided to create a contest where different students of different technical careers would compete for developing a payload that would be put into our satellite and launched into orbit. So there were 300 teams of different students, and you know, and this was mostly Argentinian students because the government of Argentina funded most of this. But there were also students from Uruguay, Paraguay, Bolivia, Chile, Peru, you know, the neighboring countries of Argentina that participated. And how the contest went, there were 300 teams, then narrowed in different stages to, you know, 50 teams, 20 teams, and so on, until 2 teams made the final. They joined forces and they developed a sensor that is going out to space in April in one of the satellites. So that is a real nice way of, you know, of maybe answering this. If you're more into the downstream side of things and the kind of use that you would, or your kind of expertise or kind of mentorship that you would seek, has more to do with you know, with making sense out of imagery or using imagery to do analysis and AI and machine learning. We also do a bit of that. It's more focused with our team in Barcelona, which is our data science team that knows about that. There's a lot of lectures that we do in universities. I gave lectures in ISU a couple of times. I also participated in a number of events with student communities in different places, and we offer this kind of help, you know, on a personal basis and from a company standpoint too. So short answer would be yes. And the last thing that I would say is when we signed, and I mentioned the memorandum of understanding that we signed with the Space Generation Advisory Council, the idea is to recruit people from there, and we use, you know, the recruiting platform and database to, we have a lot of people. Most of the people in Satellogic are younger than I am. I'm probably amongst the older 10% of the company. And many are part or have been part of the Space Generation Advisory Council. So we're very open in recruiting people all around the world. I mentioned this fact that even though we have, you know, an office in 6 countries, we have more than 35 locations where people are working for us. The pandemic taught us, you know, especially that we could work anywhere except if you're on the manufacturing team. Okay, those guys have to be in the plant, but the rest of us, most of the company, work from everywhere. And if you look at the jobs postings and positions that we have on our website, they don't typically say a given city. They say you have to be within, say, UTC -3 to UTC +3, you know, a given time frame for given positions, but that's all we demand. So, you know, we look forward to not only mentor, but also bring young people and young blood to our company from everywhere. So.
Thank you so much for that answer. And I guess today is another example of an event in which you are mentoring young professionals in this community. So yeah, thank you again for joining us.
Thank you.
So I'd like to move on to the next question by Sindhu. And I think this is also related to some other questions in the chat. So Sindhu's question is, what is the procedure to request Satellogic satellite data, and how is it different during a disaster or other crisis-related situation?
Excellent. So today we have different ways. So if you're not a client yet, if it's the first time you approach somebody in Satellogic, you would just send an email or reach out through LinkedIn or somehow, okay? We do have in our webpage, there's a click where you can fill in your data and an email will come to us, and that is another way. Now, when clients are already clients, we give them access to our platform. So they do their own requests and everything in a platform of ours. It's called Aleph, and it's pretty straightforward. And they can request for any taskings that they want, and we approve, but they sort of do their own tasking in our platform. Okay. When there's a disaster situation, this is a more expedite channel that we have, especially through UN and through NASA Disasters and other entities that we collaborate with. But it's a lot more. It has people 24/7 being able to assist in case of disasters don't happen Monday to Friday from in working hours. So we have it's sort of a bit of the same, but with a lot more concentration, making sure that we take that kind of request as quickly as possible.
Okay, does that answer your question, Sindhu? I hope so.
Yes, it is. Yeah, thank you.
Great. Okay, thank you
You're
so
welcome.
much for that. So next we have a couple of questions about startups and how Satellogic is supporting entrepreneurship community. So one question from Trong is, are you open to collaborating with startups that utilize satellite images, such as projects SGAC? And another question by Ahmed was, do you have any Middle East office for business projects?
Okay, so the first answer is absolutely yes. So we removed the startup tag from us. Okay, we're no longer a startup. We're about to go public. So, but we have a lot of a startup mentality. Okay, so Satellogic was started from scratch 10 years ago by people who didn't know a thing about the space industry. So it's sort of, we have a very peculiar story in that sense. And even though we're 300 people big, we're not a 10,000 people corporation. So we're very, very much aligned with startups. And when I mentioned the products that we are not so focused on doing the AI over our imagery ourselves, but we typically do that through third parties. So that is actually a business model that we push for, which is, when I joined Satellogic 3 years ago, we were a lot more focused on trying to do the end-to-end service until we found out that a given crop would grow differently under a given climate in a given, on a different geography. And there wasn't that much that we were learning from one project to the other, and it was taking a lot of our time. And we saw that we weren't that special, even though we have a great data science team. We weren't that special in analyzing the imagery versus any other AI company in the world, as we are in the sense that we provide high resolution, low cost, very frequent imagery. So, and that is where we are very, very unique. So we sort of said, why don't we partner with companies all around the world, trying for them to make sense out of the imagery instead, and we provide like the raw material, which is the image in the end, rather than trying to do everything ourselves. So the first part of the question is, not only we accept that, we promote it. So we are very, very focused on working through companies and organizations and individuals that make sense out of imagery rather than do it all ourselves. Okay. And in the Middle East, we have people working, we have an office in Israel, but we have people working today in UAE, and well, I cannot say it because it's a project that is still not closed, but it's about to be, but we're going to have a bigger office shortly also in another country. But again, and I may, in all honesty, I may be not aware of maybe somebody working from Turkey that I didn't know was there, because we have new people entering the company every week. So, and I mentioned Turkey, it could be any other country, but maybe there's more than I know. But there's a project that will demand an office there shortly.
Okay, thank you for sharing those insights. So I think that's it for now in the chat. So please continue asking your questions in the chat if you have more questions. And I would like to ask a question on my behalf. So coming back to the naming of some satellites. So yeah, I think this is important on a symbolic level. But my question is, has this led to any, have you felt a shift after you started this policy in terms of a new candidates applying to your company, or in terms of your interaction with clients? Did you feel some change in your business operations after this move?
Yes, yeah, it's a great question, Maximilian. Thank you. Yeah, I would say yes. So everybody likes that we do this. we do it because of our own conviction. It's not like, it's not a marketing scheme or anything, but I mentioned that I want women in rock and roll, and and I did my own list. You know, I already submitted the whys and everything. I'll win it. You'll see. If you one day you see a a satellite that, you know, with a name of some rock celebrity and a woman, you know that I succeeded. But yes, so I would say yes. It's something that it flatters us, and we all like, and, you know, of course the women in working in Satellogic are very happy with this too. But I think it's something that was due, and that, you know, and helps us learn, because many of the names that we have for our satellites, some of these women I didn't know until somebody suggested them. We have these polls where we choose the names. The last time that when we participated in this GeoInt event a month ago, where we were awarded the gold medal for multispectral imagery, we also had in our booth, we had an urn where there were people from all over could vote for the names. So we have a pool of 100 new names that we have to pick 4 from. And, you know, it's a great thing that we do it, I think. And it worked. Yes, it worked in our favor, in the sense that everybody loves it. So yeah.
Fantastic. That's really great to hear. Yeah. I'm a fan of tennis, and often in tennis, stadiums are named after famous people, and this allows their history to be investigated. So I think it's a great way to make people more curious. Yeah,
absolutely.
Great. So thank you for that response. Do we have any more questions from participants? Okay, otherwise, I think we're coming to the end of the time for this this part of the talk. So I would like to wrap up this presentation. So thank you again, Mr. Giesso, for your great presentation, and we'll be keeping track of Satellogic's next steps. Thank you.
Thank you very much.
Before winding up, I would like to request everyone to turn on their videos so that we can take a group shot, if that's okay. Can everyone turn on their video, please? Yeah, so I'll be taking the shot in 3, 2, 1. Smile, please. Okay, perfect. Thank you.
Thank you.
All right, so I guess I'll hand over to you, Sindhu and Alina, to wrap up this session.
Sure.
No?
Thank you, Max. Thank you.
Please go for it. Yeah.
Yeah, thank you, Luciano, and thank you, Max, for being here today and spending your weekend with us, choosing to spending your weekend with us. That's really, we are really feeling honored, and we really appreciate all your efforts. And yeah, the participants, of course, they have been attending 2 sessions together. So morning, sort of 3 hours back, we had another session which longed like 2 hours, and then they are here again. So I really appreciate the commitment you guys showing to this workshop, to the webinar, and to know more, to learn more from each other. So that is something that's really appreciable, and yeah, that gives us some energy also to the organizing team to actually move forward and, you know, keep working on bringing things together. So thank you, Luciano, for waking up so early. And I know it's way too early. We actually missed the daylight savings time, and yeah, sorry about that.
No problem at all.
Yeah.
Thank you.
Okay. Then yeah, we are. If anyone else has anything to add, we can actually close for today, and everyone can have a break. Good weekend. Yeah. So I take it as all are free to go. Thank you so much. See you guys in the next weekend.